Hello guys, welcome to my channel. In this video we are going to talk about value at risk using historical simulation and Monte Carlo process, and I'll show you how we implement Monte Carlo process in value at risk with using historical simulations. And I'll use Python coding and you'll have some code, and I won't explain every code because if I explain everything it will be so long. So if you have a question, if you have any question about coding, please ask generative AI before me. And if you don't have any idea about value at risk, please watch my last video. You'll have really important theoretical informations. Let's begin, guys. Let's begin. Here we need to set parameter uh, related codes and related some data. Here we will use Yahoo Finance and some libraries. Let's define our libraries here. Our first library is import numpy as pd and um, import pandas pd. I really like the cursor. This is really easy to coding. And import datetime as dt and import y finance as yf, and then here set the number of the years uh, for historical data. So years equal 15 or 20, how you wish, and dates. Yes, date time now because this is today. Okay, this is today. Sorry, guys. Really, zoom out. Yes, zoom out. Sorry, guys. Okay, guys. Sorry about it. And start date, date time delta equal 365 and my times years, because we have 365 days in a year. Then we need to define our list of tickers here. Tickers, by the way, it's up to you to use your desired tickers, I mean stocks. Last time I used SPY, Apple, and Microsoft, Nvidia, and this is showed me this, and then this is okay. And adjust clause, that's mean Dovland daily adjust clause price for the tickers. So adjusted clause, we should have adjusted clause data, okay? Adjusted clause data because without dividends, all right? Normal price and adjusted clause price have some differences, and then biggest difference is without dividend price, all right, guys? And for tickers, in tickers, right? For tickers in tickers, okay. And data equal y finance ticker start date and end date adjust class. Okay, guys, we should define our parameter here. We already defined our parameter ticker start date and end date, and data equal yf Dovland and ticker start date and end date. All right, via adjusted class. Ergo, we should continue clause define the f um Sorry, this is my bad. My bad. No, no, no. We already defined our data here and adjusted class equal uh, ticker and data adjusted class. Okay. I defined adjust clause here. We will have adjust clause price. All right. And um, print our adjusted clause defined here. All right. Print. This is I have this error. I don't know why, and I couldn't focus it. I mean, this error not about me. This error about uh, Yahoo Finance, but I won't talk about it, and I will continue. But this code is working normal days. Don't worry about it. I'll share for you. You'll see in my website. I'll continue without this coding, all right? I'll continue without this coding, but I'll give you consequences and all outputs. We will discuss all about all outputs, don't worry. Uh, this code set the time period for historical data, defines a list of tickers and outlines their daily adjusted close price from your finance, then we should have to calculate log returns. What does that mean, log return? If you focus historical simulation and another statistical approaches, you're gonna have a log return. You never have any research with normal price guys. Okay, you never have any research with normal price and simple price. Right, you always have need the log return and scale data. Okay, scaling data. So step 2, calculate daily log return, and log returns equal MP is a function of numpy. All right, MP is a function of numpy, then divided by then divided by adjusted close time df time point shift in one. All right, shift in one. Always we are shifting in one because we need to count all price with respectively. Okay, respectively. If you want to count your data with respectively, you should take df times shift in one. Okay, guys. Um, poof, 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 poof. Okay, log return np log. No, 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 no. Log return equal log returns drop na, because we will have na values and we need to drop it. We need to focus our data without na. All right, print log returns, but I never press the enter. I never try to run cut because I'll have empty output, right? Empty output. So step 3, define function expected return and standard deviation. If you are using historical simulation, we need to have standard deviation and expected return. If you focus like the standard normal distribution or cumulative normal distribution, you'll have expected return 0 and standard deviation is 1. But expected return weights and log return and return MP sum log return mean and weight. Okay, log return mean is our expected return, guys. Our expected return, all mean is expected return in statistic and finance, guys. All right, and finance. Def is covariance matrix. Matrix variance equals matrix and weight. You should have how can you find the variance and covariance matrix in statistic, and this is only coding here. Okay, this is only coding with library and root variance. All right, what does that mean? Root variance is a standard deviation, guys. All right, standard deviation. Calculate calculate uh covariance matrix, guys. Here this is the tab, calculates the sorry, no any comment. Call matrix log return covariance and print our covariance matrix and check our diagonal and non-diagonal values. If you have covariance matrix, you need to focus your diagonal and non-diagonal value and comment and discuss your data covariance matrix and their relationship between them. All right, guys. I never run the code, but you'll see all output. Don't worry. I'll fix this is failed, but I don't have more time about this. And then no important. Don't worry. Calculate our expected return and standard deviation portfolio. All right, portfolio. This is portfolio. This part creates a weighted portfolio here and calculate expected return and standard deviation. Okay, and portfolio value. Let's have a portfolio value. Portfolio value equal 1 million and weight MP array, but not this number. Weights equal MP point array, MP array 1 divided by len tickers. This code main is a kilo weighted formula. All right, a kilo weighted formula. Our stock have same weight in my portfolio. If SPY have 20 percentage, Tesla will have 20 percentage, guys. This is a kilo weighted. Okay, this is a kilo weighted. Then tickers. Oh no, MP array, MP array. No, MP array, len tickers, plus its check plus its MP array tickers times len main is size, right? Size ticker, all tickers. This is easy to understand, easy logic, guys. Coding is easy logic. Just focus what we are doing. Um, tickers, all right. Land, land tickers. What's this problem here? This problem is yes. Okay. Then weights. We already defined our weight portfolio expected portfolio uh portfolio expected return weights and log return. Yes, this is portfolio expected return mean is are defining our parameter here weights and log return, guys. Okay, portfolio standard deviation equal standard deviation weights and covariance matrix here, or else we did uh define another our parameter here. This is really easy, guys. Okay, and then we defined our parameter. Step 6 is z-score. Okay, let's define our z-score. Random z-score function. This function generate random z-score with critical component of the Monte Carlo simulation. We will have here Monte Carlo simulation and we'll have different scenarios here. Okay, anyway, diff random z car mean no means standard deviation normal. Okay, I did define it r np score non normal. Okay, zero mean is mean. This is expected return. One mean is standard deviation, guys. Variance and standard deviation. Why? Because normal distribution assume zero mean and one standard deviation, guys. Standard deviation. Step 7, scenario gain loss function calculate portfolio gain loss for a given scenario. So we need to have days is 20, and function this function calculates scenario gain loss, and let's create a function def scenario, right? Uh scenario generator, but not like not like this, not like that. Gain loss portfolio, expected to standard division days z score. Where is my z score? This is true, but where is my z score? Days z score. Okay, we defined again the function with our parameter, and then return main is run the cards. Return main is our parameter, math formulas, and times portfolio expected return times days times portfolio value times portfolio uh-oh portfolio standard deviation, guys. All right, portfolio standard devision, but we will have plus. All right, we will have days no times plus. Okay, this is Monte Carlo process and scenario gain loss function. Okay, and this code is error folio portfolio value, right? Portfolio. Monte Carlo simulations. This code runs 10,000 Monte Carlo simulation project possible feature value, feature portfolio values, and simulation equal one, no, not 100, 1,000. And scenario return is empty, guys. Okay, return is empty because this is historical, and simulation must be in this score and random. Okay, random. So scenario is empty. For in red simulation, the score randomly score this score equal random this score, yes, and scenario return then appends gain loss portfolio value expected return. Yes, this is right. So we created our simulation. We'll have 10 we'll have 1,000 simulation here, and we'll have different scenarios, but we are not created value at risk here. We just created only our scenarios here and calculate value at risk here. All right, guys, calculate value at risk here. Uh, this step calculates value at risk at 1990 percentage. I mean confidence level based on the simulation result. And let's coding our confidence interval. Confidence interval level is 90. Then we have to calculate We have to calculate MP percentile scenario 1 confidence level. Yes, this is true, but minus cancel. Yes, this is right. We have to calculate our value at risk here. MP percentile is a numpy function. Scenario return is a simulation, and 1 minus confidence mean is significance level. This is a 1%, and then times 100 is scaling our data here, again scaling our data, and then display the value at risk, print value at risk. Okay guys, print value at risk. All right, I have error here, my bad, my bad. Then plotting results. All right, plotting results. Step 9 is plotting result called visualizations. This called visualizes a distribution of portfolio gain losses over the simulated period and highlight value at risk. And let's see it. Okay, guys, let's see it. I already coding everything, and we have result here. Let's check it. Okay, let's check it. This is our set parameter here. This is our covariance matrix. Before calculate value at risk, you can focus here and diagonal and off diagonal and uh, relationship between these stocks here. This is really understanding, really easy. I mean, easy understanding. And then this is our value at risk with plotting result called visualize distribution portfolio, guys. Okay, portfolio. And this is our confidence interval, but mm, different confidence interval always have difference confidence level, confidence 1990 percentage confidence level equal, this is all right, this is 1000, uh 100,000, 60, blah blah blah. While at risk is really focusing confidence level. If you change confidence level, you'll have different consequences. What does that mean, guys? What does that mean? This logic is really easy, and how they affect value at risk result if you change confidence level. This is easy, guys, right? Always know that. Always know value at risk 1919 bigger than value at risk 95 and bigger value at risk 9. Okay, guys, always know it. If you focus tail, more tail, deep tail, you'll have big confidence, sorry, value at risk. All right, value at risk, because we have belly shaped normal distribution. Okay, belly shaped normal distribution 0, and here 95 and 99. Always this tail has big consequences events. Okay, really big different consequences events. They are not repeating always, but this number always big. If you have 10 value at risk here, you'll have 5 value at risk here. Okay, guys. If you have focused tail, more deep detail, you'll have bigger value at risk. Okay, guys, this is important. But expected shortfall have different consequences because uh, expected shortfall always bigger value at risk, but this is focusing um, outputs, but always mean. For instance, 5 value at risk have these events. I mean, this number value at risk, which expected shortfall focusing is mean. Okay, this mean divided by 5, sorry, 4, and this is expected shortfall. But value at risk focusing only biggest number. Okay, this is so uh, expected shortfall uh always have more good and more I mean better consequences, better forecast, guys. Okay, that's all what I want to say about coding and value at risk. Thanks for watching me. Next video I'll give you some explanation about uh options and some option strategies with decision trees, binomial trees and binomial distributions. Thanks for watching me. Have a nice day, guys.